Hi there. This is for pre-calculus, virtual pre-calculus. Um, I think you guys have all finished 8.2, that homework that we did on page 536. Remember, if you have any questions or troubles with those, please email me, let me know. We can talk about them as we can, online or otherwise, to straighten that out. Okay, so please don't be shy. Let me know if you're having any problems. The new stuff we're going to do today is from section 8.3 in your textbook, and it's about ways to solve trigonometric equations algebraically. Okay, and we're going to divide it up into a couple different videos here. This is the first one. Okay, so of course you can use your calculator to solve these trig equations, but you're not always going to be able to find all the solutions when you do that. So that's sort of the first issue we need to get at. And it has to do with this butterfly in the unit circle. If the solution to a trig equation happens to be x in radians, then another possibility is pi minus x. That's the second quadrant one here. There's also pi plus x in the third quadrant and 2 pi minus x in the fourth quadrant. So I'll leave that up there and keep that in mind as we're solving these things. Okay, so first we're just going to solve a really basic one. This is example 1, so you can follow along in the book if you need to. Basic equation that we can solve. Cosine of an angle is 0.6. Of course, you can use your calculator to do that, and in fact, that's probably the best way. How would you do that? Right, you just use inverse cosine, right? Inverse or arc cosine. 0.6, and if your calculator is in radian mode, then you should get an answer like 0.9273. Okay? Of course, as we know, there could be other answers. So keeping in mind this picture down here, if x is 0.9273, that's less than a radian. That keeps us in the first quadrant. Another possible solution is pi minus x. But I know that can't be right. How do I know that the second quadrant solution is not appropriate for this? What is this, the sign of cosine? Is it positive or negative in the second quadrant? It's negative, right? So the other solution has to be in which quadrant? We want cosine of this angle to be 0.6, positive 0.6. So the other angle has to be in quadrant 4. Remember, A, S, TC, all students take calculus, so the answers are in quadrants 1 and 4. So another answer would be the quadrant 4 answer, 2 pi minus x. Okay? So if we wanted to find the other one, we could just subtract 2 pi minus the answer we got. Okay, and that would be correct. An alternative way would be to view this. The coterminal angle for 2 pi minus x is just negative x, right? 0 minus x takes us to the same place. So another way to talk about this quadrant 4 angle would be to just always call it negative x instead of 2 pi minus x. Okay? So probably the easiest way to describe the solution to this equation is plus or minus 0.9273. Okay? So that incorporates both possible answers. Now we also know that because these functions are periodic, we could add plus or minus 2 pi n to that. Right? So depending on the way the question is worded, we may have to add that to our answer. Alright, another simple example, and then that'll end part 1. Okay, what if we have one like sine of x equals negative 0.75? This is example 2 from your text. Okay, same idea. We're going to take the inverse sine of minus 0.75. What two quadrants are we going to find ourselves in? Right, if sine is negative, that's got to be quadrants 3 and 4. Right? So we take the inverse sine of negative 0.75 with our calc, and we find that x has to be negative 0.8481. Okay, so that's one of our answers. negative 0.8481. That must be this one, right? Right, in order to get over here, we'd have to have negative pi over 2 radians, which is more than negative 1 radians, right? So this is still in quadrant 4. This first solution we found is in quadrant 4. In order to find this solution in quadrant 3, well, what we can do is we can view x as 0.8481, and we can say, look, this quadrant 3 answer is always pi plus x. Okay, so we can add pi to this. Pi minus 0.8481, and that gives us our second answer, which is, I'm sorry, add pi to x, not add pi to minus x, right? This first solution we found was minus x, the fourth quadrant answer. If we add pi to x, we're adding pi to 0.8481, and we're going to get 3.9897. Okay? So those are the two answers for that equation. Of course, again, you could add 2 pi n to either of them. Okay? But just adding 2 pi n to this one is never going to get you here. And so you have to be careful to account for both sets of solutions. There's a set of solutions that is equal to this plus 2 pi n, and there's another one that's equal to this plus 2 pi n. So you have to catch them both. Alright, there's what's called a solution algorithm on page 540. Okay, and maybe if you're a little bit lost about all this x and pi minus x and pi plus x and all that, maybe you want to check that out. I don't like that thing because it's a huge thing to remember. I'd much rather just think about this picture and figure it out each time. But if you don't like that, if you'd like to have something that always works, that you can memorize or put on your cheat sheet, this is the thing you want. Okay, so I'm not going to teach that to you. If you really want to use it, figure it out and use it. But you can always figure it out by using this unit circle and the butterfly picture. Okay, that's all for now. In part 2, we're going to do some more examples. See you there. Go back out.